Well, that's just the recording. You don't need to have it. I think you want the recording. Here we go. All right. So, we've made it to one of my favorite lessons of the year, which is the addition. Thank you. So this is 6.6. This is the what would I call it? Like the lesson before the last lesson, the semi-last. Oh my God! Anyways, I don't want to waste time because this is really fun for me. I want to do a few problems with you guys, show you how they work. Thank you, thank you, thank you. Get rid of your earbuds, please. Thank you. So let's just get to this. Wrong way. Today you're going to understand, hopefully, how you're supposed to add, subtract, multiply, divide polynomials. Okay? And then there's going to be a little piece on this thing called composition of functions. Really fun stuff. The first ones, they're just arithmetic. Add, subtract, multiply. You should be able to do that. But the compositions is what I really like to do. It's really fun, I think, anyway. You've got those two slides with your rules. You should already have those inside of your student companion. Make sure that you're looking at that. If I'm not telling you to bring it out, you should take notes on it. Make sure that you know where stuff is at. Because one day I might be like, hey, this final's coming up. You can put a little bit of notes on there. You want to know where they're at. And here's a slide on composition of functions. If you're a math person, that makes a lot of sense, but I'll explain to you what that means when we're doing it. Deb, get rid of the headphones, please. So, adding and subtracting functions. Here we've got two functions. We have the f function, and then we have the g function. Does everyone see that there are two separate functions? And we have to add them. So let's do that operation first. This is saying take f and add g to that. So I'm going to start with f, and I'm going to add g to that. That should be your first setup when you're trying to add these things. What's going to go in the first set of parentheses? F, right? Which is 4x plus 7. What goes in the other set of parentheses? The g function, which happens to be radical x plus x. Look at? Now this just means I'm going to add. Does this symbol affect the right side of that in any way? Yeah. How? No. It doesn't. Because a positive times a positive is still a positive. Positive times a positive is still a positive. So what I really have here is simply 4x plus 7 plus radical x plus x. What should I be doing at this point? Combining like terms, CLT. This 4x and this x become 5x plus 7 plus radical x. Can I add anything else? You could square root that. No. There's no equations. I'm not solving for anything. All I'm doing is simplifying. Can I simplify further? Oh, you could put it in. Yeah, I could. But technically I'm done at this point. That's it. I just added the two. Questions on that? Well, we're only doing the addition part right now. I want to make sure everyone's okay with the addition. Deb, you go with the addition? Close your laptop, please.
Yeah, 1 plus 1 equals 2, and 2 plus 2 equals fish.
Yes. I can get rid of this? Yep. All right. Yeah, go.
You have to make sure that change it.
Well, it said do f plus g. So all I did was plug in f in here, which is this piece, right? 4x plus 7, that was in there. And then it said plus g. G was, which is this piece, just went inside of there. That's it. And then add them. Well, in that case, yeah, if I have an addition symbol here, it's really like I have to distribute that positive, right? But a positive times a positive is positive, so that says positive x. Positive times positive x is still positive x, so, okay? And you'll see how that does matter, though, when you're doing the subtraction. And you can kind of foresee it already, right? If I do have a negative up front, then what happens to everything on the right of that? It changes its sign. It changes the sign. Are we good there? All right, so there's the addition one. Bye. Stay over there. Let's do the subtraction one. Something minus something. What goes in my first block? We're doing the f minus g now. So what should go in there? The f function, which is 4x plus 7. Over on the other side, I have to put in the g function, which is square root of x plus x. Notice in this case, the subtraction does affect the right side of the equation. 4x plus 7 stays the same, but that becomes a negative radical x and a negative x. At this point, I do CLT. You need to combine the like terms. 4x minus x is 3x this time. I can't combine any other stuff, so I've got plus 7 minus radical x. So here's the subtraction of the two. Now, I don't know if Excel will let you get fancy and make that negative x to the 1/2. Try it if you really want to know. I would say, why do more math? Because you're going to do more math, there's more room for errors, mistakes. Yep. Don't want to do that. It looks so empty today. I guess I'm starting to feel like 40 is normal. Actually, it's 41.
That's it. Big difference.
Yeah. Well, it's better than my 4th hour. It's 43. I'm still getting more. I got a new one yesterday. That was awesome. I'm gonna let everybody sell the counters after that. Like, there's no more chairs, but you can sell the counters. See, who's not here? Finn, you okay back there? 2 Saints gone? No 2 Saints? No Kindle? No Deandra? And Rodrigo? Okay. We're good? Jaeger? All right, moving on. You try. Go. You got 2 minutes here. Do the addition. If you have time for the subtraction, you can do subtraction. 6.6.
Write on the dirt, it scratches your feet. So they wrote in dirt on my hands. So it wasn't like writing. They still scratched my name. And I just got back on it. I was catching me at the library. And she told me she would ask me. I told her this is a teacher. I was like, if you get hit, she's going to do it. Yeah, I know. Either way, she said that I'm just going to fight.
All right, that's fine. What are we gonna call it?
I got it.
Jose, what'd you get? Shh, on the addition one. 2x squared plus x plus 5. Can I get a second, third on that? Second that, third that. Good job. Here we go. Boom. All right, do the subtraction one. Do the subtraction.
Can I give you answers?
We're working on that decimal part.
Huh?
We give you guys a minute. I think 2 is too much. 1 minute, do the subtraction one. Go. You already did it on the last one. Pretty simple, I think. What has to be different? Than that?
She has my address. She's been in my house. Are you trying to go over? Do you want me to go? I was just asking her if she had service.
Oh, that's a pretty picture. Put your phone away, sir. Okay, who's got the last one here? Let's see. Question goes to.
Yeah, how do you say that?
Stephanie?
Oh. I just saw a big word.
2x squared minus x plus 11. Can I get a second and a third? Second, third, fourth. Nice. Good job, guys. This is so easy, yeah? All right, so let's change it then. Let's multiply and divide. Whoa, commentate. All right, so let's start with the multiply first. I've got x squared minus 9 getting multiplied by x plus 3. How do I do that? Nice and loud? Just FOIL that. Yeah. So, start with x squared. That's going to give me x to the third. This will give me a positive 3x squared. This will give me a minus x. This will give me negative 27. Is there anything else to do? No, we're done because they're not like terms. Math.
You get too excited for this.
I can do this all day. I will be doing this all day. 3 more times. Give you guys a second to copy that down. Get some points over here too, Stephanie. Good job.
Math.
Write it down.
You look like a ferret.
Here's how to do that. But it's funny. I get like a cramp almost when I do because I forced it to kind of close. I know, but it's funny though. It's worth the laugh. I know. What are you, parents? You make that face and stay like that. That was the biggest lie ever.
I used to cross my eyes when I was a kid.
We know we
Doing
died.
that, you do stuff like that.
I know. That's like. That's why we lose trust in our parents, right? Nobody tells these things aren't true. I remember like a kid, I'm like, after I had the watermelon, can I get some milk? Like, oh, you can't do that. You can't cross watermelon and milk. Nope. Like, you just didn't want to give me no milk. No, that's what I'm telling you. Like, parents like make up stuff. You shouldn't jump in the shower after you like been working and stuff.
Into the shower at all.
You shouldn't. Yeah, touche. I used to do this as a kid. Okay, we're done. Thank you. That's why I can't say nothing. You say something like everybody have a conversation. Thank you.
You're welcome.
Thank you. So let's do the division here. Now the division is a little bit trickier because there's a little bit more thinking involved. I mean, the multiplication one, of course you got to do some thinking. But hopefully you see that this is simply going to be f over g, right? So this is x squared minus 9 over x plus 3. We're not done. I mean, that's the basics of it, but we're not done. The top can be factored, can't it? Anybody recognize that that's just going to be two conjugates? That becomes x plus 3 and x minus 3 over x plus 3, correct? Can that be simplified? Yeah, how so? Well, x plus 3 over x plus 3, this is 1. And 1 times x minus 3 is simply x minus 3. And there's my quotient. Now, if you want to throw that into some synthetic division, go for it. If you want to do some long division, go for it. But I know how to factor that, and that was much faster than any one of those two. But that's it. There's the quotient, x minus 3. Questions? Going once? Twice? Okay. Put my marker away, man.
Oh, now we're not a clean marker.
No, you may not. Hold it forever. 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 You need to watch that movie.
Sandlot? That's like really good.
That's a great movie. They had to ruin it with Sandlot too.
The second one.
It was a copy of it, but it was like not as entertaining.
That's what it is with the Little Rascals too.
Yeah, I never watched Rascals 2, just the first one.
Yeah, it's pretty pathetic.
They just copied them all.
And I just,
They did, and it's not good. There's only a few sequels that are actually okay. Like I can watch Cars 2.
I really love that.
How to Train Your Dragon.
No, I don't have driving strength.
You don't like How to Train Your Dragon?
All right. Okay, you try.
I'm not even kidding.
I'll need a reason.
Please remind me to go back and talk about the domains. Before I forget.
No. I mean, yeah. I already forgot. Domain.
Oh, right. Because they'll remember.
Oh. It's okay.
I'll just shake my finger.
Did you just search the computer? I'm so not
Give you guys 2 minutes for both of those. Ben, you okay back there? No, that's the old schedule. I need to edit that, but I'm too lazy. I'm too lazy to do it.
How would you know?
Adam. I'm on it. Why don't you just factor it? Oh, no. What do you do? Multiply this? Did you boil it out? What? Yeah, I'm noticing that a lot of you guys are. Let me go and stop you there. I'm supposed to multiply 3x squared minus 11x minus 4 by 3x plus 1, right? I mean, everyone understands what's... Thank you! Everyone understands what's supposed to happen. Doing it is kind of the tougher part. If you don't want to sit there and do all these little arrows, then you can do this the way you used to multiply in elementary school. Okay, just like that. So let's start. What is 1 times negative 4? Negative 4. What's 1 times negative 11x? Negative 11x. What's 1 times 3x squared? That is 3x squared. 0 for place value. So now we go to 3x. What's 3x times negative 4? Negative 12x. That should be a plus 0. And then 3x times negative 11x? Negative 33 x squared. And then 3x times 3x squared? 9x cubed. Now we can add them all up. So we've got 9x cubed minus 30x squared plus x minus 4. The 12's supposed to be negative. Yeah, the 12's supposed to be negative. Good looking out, good looking out, good looking out. This is supposed to be a negative 12, which makes this a negative 33x. 23. JK, smiley face, LOL. Watch me write 33 again. There we go. Questions? Just need to write it down. Recording right now. No, it's not. It's not appropriate. back, we're done. Stop. So there was the multiplication one. Let's move that out the way. Let's do the division one. So for the division, you're going to get 3x squared minus 11x minus 4. That's being divided by 3x plus 1. Just a heads up, little tip here. Usually when you're dividing and you got a numerator like that, usually the numerator is going to have a factor of the denominator because what they want you to do is cancel out. So I'm going to just go with that assumption for now, that this numerator is going to have a 3x plus 1 in it, as well as the denominator. Okay, now if you want to do long division, go for it. More power to you. Right, Alyssa? All I need to do now is figure out what goes in the other binomial. Well, to get 3x squared, I just need another x, don't I? To do the last one, I would need a negative 4. So all I'm doing right now is I'm just finishing this up, and then I'm going to check to see if my theory is true here. So for the outside, that's negative 12 plus 1. Does that give me my negative 11? Sure does. So that makes 1. And the quotient is x minus 4.
Can you just factor out the 3x squared minus 11 and get those same two factors right there?
You factor them out.
Yeah, like.
What do you want to do? Tell me. I'll write it up.
Multiply the negative 4 times that 3 and like,
Yeah, that gives me negative 11. Or negative 12, I mean. What happened?
Feel the tension in here.
Oh, no tension.
That's really I can feel it.
No, you want to feel the tension, wait till we get to the finals week. And I've got people emailing me talking about, Mr. Munoz, I need to pass. What can I do? Yeah, that's going to be me right there. I told you guys day one. What do you need to do to pass?
Emily, you said we had to try it. You said
Oh, yeah. Oh, you're talking about, no, I think you're going to do fine.
The homework and the word.
If I had an 89, like, what are we gonna do about that?
Jaeger does not want to hear your complaining about your 89. Right, Jaeger? You just need to be quiet.
We want to end the semester with an 89.
But see, you just made my point, because you've been trying the whole time. I don't think you have anything to worry about. I really don't. All right. So, questions on that? Everyone's okay? I do want to go back and talk about something that I skipped on every single problem, which is the domain. You need to know and you need to figure out what the domain is going to be. The domain is simply asking you what is x, or what's the value of x. So if I go back to that first problem, right up here, we had this thing in there. So if I want to throw it into Desmos, take a look at the graph, I can. See if I can do that. Desmos. So what was that? What was that function? 3x plus 7. So 3x plus 7. 4x? 4x plus 7.
Just go back and look.
3x. 3x plus 7 minus, and I still made it apart, didn't I? 3x. I think the other one was a 5. Minus the
Square root.
where did square root at? Square root 2x. Okay.
How are we supposed to know that that was there?
But that's what?
Square root was there. I didn't know that was in there.
Because I told you?
No, in Desmos.
Because I told you. Yeah.
We did not have a training course.
So anyways, here's my graph. I want you to notice that there's no part of the graph on the left side, right? You guys see that? There's nothing below, what is this, 5 or something? 7? 7? So anyways, for this problem, if it's asking for the domain, all it's asking for is for x. So I'm going to go over to the x-axis. What's the smallest x I have? Happens to be 0, isn't it? And it goes that way? So my domain in this problem would be x is greater than 0. Where I can say all positives, anything that describes the set of x values that the graph takes on. Make sense? Okay. Sometimes you're going to get linear functions. Maybe something like, without this radical, something like this. You guys know lines go on forever in both directions, right? Yeah. So what would the domain in this case be?
Negative.
Any numbers you want. I would just say all real numbers. Okay? I do want to show you some of the other ones. Well, like that, that's a quadratic, right? Let's go and plug in 2x to the second. What was the rest of it? Anyone remember? I wonder you guys have photographic memories. Minus x plus 11. Minus x plus 11. So here's my parabola. Now, technically, what is my domain here? Clear ink. What is my domain? Well, this thing's going to keep growing, isn't it? Forever? Which means it's going to be every number in that direction, but also grows that way, which means it's going to be every number in this direction. So my domain is all real numbers. Since we're there, good job. Since we're there, though, let's talk about the range. Range is a y value, isn't it? Is y anything less than whatever that looks like 11 or something? No. So what would the range be in this case? Anything greater than 11. Make sense? All we're looking for is what x can't, and cannot be. And I keep saying it that way because there's some strange situations. For example, the ones we just did, the ones we just divided, where'd they go? Is that? Okay, so in this case, they're going to ask you, what is the domain of this problem? Our problem simplified to this, didn't it? That was a simplified problem. Was that the original function? It was not. What was the original function? This one right up here, the whole thing. So if I take that into Desmos, which is the, what is it, x? I should just do my position. Here we go. X to the second minus 9, and then this was x plus 3. So I'm going to get this here. Okay. It's going to give you that last one you guys had, right? Do you guys see anything wrong with this graph? Did you see nothing wrong with it, right? It's just a line. Well, it's a little bit more complicated than that. Okay? Let's go back here and use our brains.
What's that?
Yeah, I know, huh? Let's say that I picked x to be -3. What's wrong with that? What's wrong with picking -3? What happened? Well, according to this graph, x can be anything, right? But let's say I said, hey, I want x to be a -3. Does anybody see any problem with that? Adam? Do you? Okay, I want you to focus here. Let's say I did make x -3. -3 squared is 9. What's 9 minus 9? 0. What if I put it here? What's -3 plus 3? 0. Can I have 0 in the denominator of a fraction? Why not? It's undefined. So, even though I get a graph and I get a polynomial that says, hey, x can be anything, can it really be anything? No. That's why you need to go back to the original, make sure that you check that everything is hunky-dory there, that you don't break the math. And in this case, -3 would break it, wouldn't it? It will make the denominator 0. So for this case, you could say, hey, the domain can be any number except?
3.
Except for -3. Okay? So I'm just throwing that out there. Be careful with that. The math part's not too difficult. Just got to think about it a little bit, okay?
Are all of them like that?
Anything that you divide. Now, usually if you get just one polynomial, like when you're multiplying or adding, subtracting, you don't really have to worry too much. But you do with the others. Okay. I don't want to run out of time, so I'm going to jump into the composition of functions. My favorite part. Yay! Does everybody know what Russian nesting dolls are?
Yeah.
You guys all know? What are Russian nesting dolls? Okay, only 4 of you at the same time.
Dolls inside of dolls inside of dolls.
Wallace, what is it?
What he said, dolls.
Boom, it's a doll inside of it, right? You get a doll, you open it. Oh, there's another doll in there. You take that out, you open it. There's another doll in there. That's entertaining. It's like it never stops.
No, I get pissed. I would stop.
Well, then you're not going to like this very much. Thank you. Thank you. Now I'm going to show you how to do this so that it works for any problem that you do. Okay, because they're going to get a little bit tougher. So the way I'm going to show you is the most effective that I like. Do you guys see this up there? I don't know. Has anybody seen that before? No. It says GOF, doesn't it? GOF. GOF -3. What is a GOF? When I first saw it, I was like, what? Now we're putting sentences and words into math? That actually means, okay, does everybody know what f of x means? Everybody knows what f of x means, right? It means you got a function, you plug in x. So if I said f of 3, what would x become? 3. So I have a function, and for every x I plug in a 3. This is one way of writing g of something. And what I'm plugging into this g function is I'm going to nest inside of that the g function, not the g, I'm just kidding, the f function. So this would be f of x, I should use another color, f of x inside of the g of x. And then inside of the g of x, what am I going to put in there? -3. So I would have g of x and then f of something, and then what I throw in there is a -3. So this is another notation. These two mean the same thing. Just throwing that out there. If you want to know which one the main one is, start from the left, just like we read our books, right? Left to right. So the main function is g. What goes into g? F. And then once I have that, what goes into that? -3. So same thing here. G of f of -3. It looks bad, but it's not. So let's find, this wants us to find g of f of -3. So what is my main function? What's my main function here? It wants me to find g of -3. What is the main function here? The g function. So I'm going to start by writing g, which is x squared. Okay? Step 1 okay? That's not okay? The first function they want me to use in g of f is g. That's why it's first in line. Oh, I don't know. I'm trying to... That's first mistake. Sorry, I'm to tone that down a little bit. I'm embarrassed right now. So the first function I want to use is the g function. Okay, so I go over to g, and it says, oh, look, g is x squared. So I write x squared. Okay? All right, so we're good now?
Yeah.
I don't know why I was getting louder. Like it was going to make more sense, right? Just, no, he's not. Okay, so I got to plug something into this. Where can I do it? Somewhere, right? The only place is x, right? Because does 2 change ever? Shouldn't. So I'm going to write this because I got to plug something into x. What am I putting into x? What am I putting in there? The f function. The f function. So I'm going to go over to f and figure out what that is. What is f? It is x minus 5. You cool with that? Okay. I got to plug something into that. Where is the only spot that I can plug something into?
5.
The x. So I'm going to write x minus 5, close, and then the 2. And what am I throwing in there? A negative 3. I should use another color. I'm going to throw in the negative 3 in there. So negative 3. And then I just do it. Because there's no more variables, right? So, what's negative 3 minus 5?
When you times that?
No, there's a negative between them.
Okay.
So that's negative 8 squared, which makes 64. Not so bad, right? Fun stuff.
So you're just plugging stuff in.
Yeah, Russian nesting dolls. Throw this into this and throw that into something else. Over and over again. Now, it really does matter because sometimes, instead of saying find g of f, they might also say, also find f of g. So here's a couple of things they might ask you. Giving you those functions, in this case they said, hey, find f of g, right? They might say find f of g of negative 3. Or they might even say, for some crazy reason, find f of negative 3. Or they might even say find g of g of negative 3. Hey, GOG. GOG. You guys want to try GOG real quick?
Yeah. No.
So, I'll use red. Because it's not that bad. What's my main function? G, which is x squared, right?
Yeah.
And what am I putting into x squared? X squared again, because I got to go here.
Right.
So this becomes x to the 4th. And what goes into that?
3.
The negative 3. So negative 3 to the 4th, which would become 81. That would be done.
Would it be?
Okay, Russian nesting dolls. Well, something goes into something, goes into something. Cool with that? All right.
No, it is.
That will work for anything. Okay? That will work for anything. Now, Jesus, since this one actually has a number at the end and not x, we could actually do something that's probably going to be a little bit easier. Yeah, you all like easier, right?
Plug it in there then.
No. If this is asking you to evaluate a number, you might want to hear this. You might want to hear this. If this is asking you, the composition wants you to evaluate where there's a number, the easier way to do this is to do this backwards. Now this only works when you're evaluating a number. Okay? I'm going to take 3 and I'm going to plug it into the f function. So go over here. What's negative 3 minus 5? It's negative 8. I need to take that and plug it into the g function. So what is negative 8 squared? There's my 64 again. That only works when you're evaluating some number. If x is there, it's not going to work, Jillian. If there's an x there, it's not going to work. You got to do it the long way. Okay? So let me show you that again. I'll do it the easy way first. Here's negative 3. So I start with negative 3, it goes into g. G is x squared, which means negative 3 squared, right? Which means 9. Where does that 9 go? Into the f. So what is 9 minus 5? And I'm done. Only when there's a number there. Did they ask you to find? Now, let me show you the difference. See how that says f of g of negative 3? You can do it that way. But if this says f of g of x, all bets are off.
What if it's like x of negative?
Doesn't matter, as long as it's a number, an integer.
Oh,
As long as you got some integer in there, you can do it backwards. Kind of like putting the next thing all together. Questions on that? That's all I got for you guys.
Finally.